Concrete is 10 times stronger in compression than it is in tension. The press you see here is actually testing the compression strength of concrete. It's going to squeeze that concrete cylinder until it crushes. Then they'll document the PSI of the concrete. Now we're going to talk about different forms of reinforcing concrete with steel. Wire mesh, first of all, is not required by any particular code in a slab. Some guys like to use it. It does not keep any concrete from cracking. What it does is it stops when the concrete does crack. It stops the crack from separating and changing height, so it'll try to maintain a smooth surface. It should be placed on chairs so it's kept at the right height, the proper elevation throughout the pour. The method of just laying it on the subsoil and then pouring the concrete and trying to lift it while you walk on it, yeah, it doesn't work. You got to have it held at the right level. It's easier to use sheets like you see in this picture than it is to use the rolled stuff, because the rolled stuff's hard to get flat. It's just better off not to use it most often. Just step up in the concrete strength. Go to a 5,000 psi Aaron-trained concrete if you really want that extra strength. Now, re-rod, you might use it in a foundation or a wall or a footing. We'll call it rebar or re-rod. The markings on it, you'll see, it'll say steel mill, then the bar size. This one says 13. Then you'll see steel type, and you'll see grade. The English way of sizing rebar or reinforcing steel is in eighths. So if there's a number 5 on the bar, it's going to be 5/8 in diameter. So if something calls for number 5 bar, that's 5/8 bar. Something calls for number 4 bar, that's 4/8 or 1/2 inch. So 4/8, 1/2 inch. Okay? So that's when it's in the right place, it's going to actually increase the strength. The reason it's deformed is so the concrete can grip it. Is this going to stop it from cracking? Not necessarily, not unless it's pre-stressed, which most often it's not. So is it going to stop it from cracking? No. Will it give it more strength? Yes. Is it going to give it some tensile strength if it's put in the right place? Yes. It'll do all those things. When you put it in place, you have to hold it in the right place, so when you pour the concrete on it, it doesn't get dislodged or moved, because remember, I keep talking about it's got to be in the right place. So these are going to be ties that we're going to use. These tools we will actually tie the rebar together so it stays in the right place. Now, if this is a beam, okay, we're going to call this a concrete beam. We're going to apply a load to the top of it. We've got a neutral axis. There's no loading at the neutral axis. And then you've got compression. It's going to be squeezed together on the top and pulled apart on the bottom. You have to have the rebar placed in the lower third. Okay, divide this into thirds. It's in half now, but you put that rebar in the lower thirds and it's going to greatly increase the strength. The picture below, the load's on the top of it, causing the beam to sag or deflect. It'll crack on the tension side, which is the bottom side. The area being stretched or pulled apart is the bottom. That's the tension side. Concrete that's not reinforced has very little strength to resist this. Proper placement of the rebar is critical to improve that compression strength. When you're pouring a foundation wall, you want that concrete to be towards the inside of the wall, not the outside of the wall. You want it to be towards the inside of the wall. It needs a certain dimension of coverage, but you want it to be on the inside so it has that tensile strength on the backside.